All right, I'm gonna try one more induction one. This is one where when I look at it, I don't immediately see how to work it out, but I'll try it out. And so if this video gets a little rough when I have to think through stuff, that's okay. That's part of the learning process. I don't automatically know the answer to everything either, and I just have to kind of go through the logical process. So I'm looking at exercise 2i that turns out to be on page 51. So I'm looking at 2 to the n plus 2 plus 3 to the 2n plus 1. N is a positive integer, and we are divisible by 7. Okay, so the base case, we plug in 1 because we're in the positive integers. Yep, so let's plug in 1. So 2 to the 1 plus 2 plus 3 to the 2 plus 1. What does that equal? 2 to the third plus 3 to the third. 8 plus 27 is 35, and that makes 7 times 5. So check mark. We have the base case down. Next, assume that the statement is true, i.e. that it equals 7k for some k that's an integer, because that's what divisibility means. Okay, and let's look at the next one. So then consider the n plus 1 term. So that's going to look like this. 2 to the n plus 3, because we were at n plus 2, we're looking at the next term, plus 3 to the 2 times n plus 1 plus 1. Notice I did it inside the parentheses because I'm looking at the next term when n becomes n plus 1. Okay. I don't see really how to work with this one. I know I'm going to want to use my induction hypothesis somewhere. Let's see. What can I do? I can make this 2 times 2 to the n plus 2, because then that kind of looks like the induction hypothesis. And I can make the other part 3 to the 2n plus 3. So I guess I could make that 2 times 2 to the n plus 2. And then here I've got a 3 right here, and I want it to look like a 1. So that's like 2 extra powers of 3. So I'm going to draw down a 9, because 3 squared is 9. So I have 9 times 3 to the 2n plus 1, because I pulled out a 3 squared, so I still have a 1 left over. Okay, that's a little weird. I don't know if it matters which way I go. I'm going to try to use the induction hypothesis here. So I'm going to rewrite it. I think it should be okay to work with it either way. Maybe this is easier. 2 to the n plus 2 equals 7k minus 3 to the 2n plus 1. And I'll take that and do a little substitution right here. We'll see if this works out. Like I warned you at the beginning of this video, not sure I can see the whole pathway on this one. So we'll see. So 2 times my substitution, 7k minus 3 to the 2n plus 1. Yep. Plus 9 times 3. Oh, that's cute. Okay, I see that this is going to work out. Great. So distribute it out. So I'm going to do, if you watch the previous video, you'll see I've done this trick before. I only want to prove, remember, what's our goals? We want to prove it's divisible by 7. So I want to end up with 7 times something. So I'm going to distribute the 2 in kind of a weird way. I'm going to do 7 times 2k minus 2 times 3 to the 2m plus 1 plus 9 times 3 to the 2n plus 1. And then these two things are like terms. So now we have 7 times 2k plus 7 times 3 to the 2n plus 1, which is 7 times an integer. And so there we have it, folks. It is divisible by 7. And so by induction, you know that that expression is divisible by 7 for all n. And that's it. So please ask questions or comment if anything was confusing, and I'm happy to help out. There you go.